Hello everyone. Today I want to explain you or introduce you about the lesson of which we study about determinant. So the first we should be know what is the determinant. In our general study, I heard that you have studied about metric and determinant, but only 2 by 2 on this time. It means you study only 2 by 2. So on that time you have to know about the if you have the metric A, example metric A is equal A, B, C and D, and you have the determinant of A, you can write in like this, and the absolute of A, B, C and D. So it equal to AD minus BC. This one is the determinant of about the metric A. This is in the metric 2 by 2. So now we can continue from 2 by 2 to 3 by 3, 4 by 4 and 5 by 5 until etc. So this is our determinant. Before we go to determinant, I want you to know what is determinant function. Determinant function is the function that we relate to our natural number or our number by permutation. So in this case, is we start about the permutation. Is the permutation. Permutation it means that if we have AB, we can write to AB or BA. This is we call about the permutation. Permutation between A and B, we have only AB or BA. This is the meaning of permutation. That is about the natural number. What is natural number? Natural number in our lab, we learned about n. This n is for natural number. Natural number is the number is positive number. Positive number but non-zero. This is the natural number. Natural number is the integer take about the positive number, but it's non-zero. So if we have about this natural number of 1, 2, 3 until to n, this is the natural number 1, 2, 3 until n, and we can write by this form I1, I2, I3, I4, I5 until IN, where I1 is the first permutation and I2 is the second permutation. And about the I3 it means that is third permutation. And about EN is an permutation. This is the kind of letting by E1, I1, I2, I3 until IN. And this is the classifier of our permutation. So this example, find permutation of 1, 2. 1 and 2 has permutation 1, 2 and 2 to 1. Has only 2 of permutation of 1 and 2. So permutation of number about written by 1, 2 and 2 to 1. And example, find permutation of 1, 2 and 3. Permutation of 1, 2 and 3 can be written in this form. It can be written by this one. This is the permutation of 1, 2, 1, 2, 3. The permutation of 1, 2, 3 is 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, and 3, 1, 2, and 3, 2, 3, 2, 1. This is the permutation of our number 1, 2, 1, 2, 3. This is the permutation. In this here, also we can call this permutation of and get 2, 1, 3. Or we have 1, 2, 3, 1, 3, 2, 2, 3, 1, 3, 1, 2, and 3, 2, 3, 2, 1. This is the permutation of our writing by from the permutation of 1, 2, 1, 2, 3. So the permutation of 1, 2, 3, we can get 6 of permutation. It is here. And then we get about this point for this about we can write this permutation 1, 2, 3 1, 2, 3 by example we have this permutation. So we can write this permutation 1, 2, 3 as 3 diagram as soon be below. So the first you take 1, you take 2, and you take 3. And then this one is you have 1, but you have this 1, 2, and 3. 1, 2, and 3, but this one you have only number 1. So you have remain number 2 and number 3. This one is number 1, number 2, so you leg off number 3. This one number 1, number 3 is you leg off number 2. This is the kind of our permutation by as 3 diagram. This also like you have number 2, you leg off number 1, you leg off number 3, and number 3 and number 1. And in this case also the same as the first which I told you. Example, in this case you can write in other kind of tree diagram. Example, you get I write in here 1, 2, and 3. This one is get from the same branch. This one you divide by 2. The first is 3, 1, 2, 3. But the next step is only 2 because you have only 1. So you leg off or you don't have number 2 and number 3. This one you have number 2. So you lack of, or you don't have number 1 and number 3. This one you have number 3 and you don't have number 1 and number 2. In this case, from this one we get 3 branch or 3 branch of tree diagram, and beside we have 3, we have 2 branch. We have 2 branch. After 2 branch, we have 1 branch. 1 branch, it means that 1, 2, and you don't have 3. 1, 3, you don't have 2. This one, you don't have 3. This one, you don't have 1. This one, you don't have 2. This one, you don't have 1. So you get the result is 1, 2, 3. 1, 3, 2 is 2, 1, 3 is 2, 3, 1. This one is 3, 1, 2, and the last one is 3, 2, 3, 2, 1. So we get the same result as our tree diagram. This one we can call also tree diagram, and this one is also tree diagram or also. So sometimes they led by this sign, or sometimes they led by the design. It's up to you. Which one you like, which one you want to write is up to you, because it is not which one is correct or which one is incorrect. No, it is correct or both of this tree diagram. And the next notice number of permutation. Number of permutation. Number of permutation 1, 2, 3, 4, 5 until n is written by n factorial equal to 1 multiplied by 2 multiplied by 3 multiplied by 4 multiplied by until n. This is the permutation of 1, 2, 3, 4, 5. Example, you have permutation. Example, we have 1, 2, 3, 4 in this point. So the number of permutation. Number of permutation is 1, 2, 3, and 4 equal 20, 24. So permutation of 1, 2, 3, 4 has 24 different permutation. Example, you have 1, 2, 3, 4, and 1, 2, 4, 3. 1, 3, 2, 4. 1, 3, 4, 2. This is the kind. And 1, or example 2, 1, 3, 4. 2, 1, 4, 3. Or 2, 4, 1, 3. And this thing. It's until to 20, 24. This is the kind or the kind of our permutation from number 1, 2, 3, and 4. And we have 24 permutation of this point. So example 3 also number 1, 1, 2, 3. It has 6. Why it has 6? Because we count already. This one is 1. This one is 1. This one is 1. This one is 1. Also, about list of number 3 is also this one. We have 1, 2, 3, 4, 5, 6. Why we get 6? Because 3 factorial is 1 multiplied by 2 multiplied by 3 is equal 6. So permutation of 3 number is 6, permutation of 4 number is 24, permutation of 5 number, example 1, 2, 3, 4, 5, it's equal to 24. This one is 120, because 24 multiplied by 5 is 0, carry 2, and 10 plus 2 is 12, so we get 120 permutation of 1, 2, 3, 4, and 5. And now we just go to our, this is and the next they want us to find about the inverse of permutation below. Find about the inverse of permutation below. How can we find about the inverse of permutation below? In here, they have about this example. We have number 1. We have permutation of 3, 1, 4, and 2. This kind we explain about this 3, 1, 4, and 2 has number of inverse written by. This one have 2 inverse, this one have 0 inverse, and this one have 1 inverse. So why this one is have 2 inverse, this one is have 0 inverse, and this one is have 1 inverse? So the first we just look from the right, the left to the right. This one is 2 inverse. Why it get 2 inverse? 2 inverse because when we count from, example in this here, I count from the right or the next of number 3. The next of number 3 we get number 1, number 4, and number 2. Number 3 is the first, the leading number 3. If we count next number 3, we find about the number that is smaller than 3. The number that's smaller than 3, how many number that's smaller than 3? This here we have about smaller than 3, and we have number 1, and we have number 2. We have 2 number that's smaller than 3. If we have 2 smaller number than number 3, it means that it has 2 inverse, because the right of number 3 have 2 smaller than 3, so it has 2 inverse. And then after we finish about number 3, we start the next from number 3 is number 1. Number 1, and we count the right of the number 1. How many number that's smaller than 1? In the right hand side, this side, how many number that's smaller than number 1? We don't have. In this hand, we don't have number that's smaller than 1. So if we don't have the number smaller than 1, it means that this permutation has 0 inverse, or don't have inverse in here. And the next number 4, we look to the right hand side of 4. The right hand side of 4, the number that's smaller then 4 has only 1. It's number 2. It's number 2. It means that it has 1 inverse. In this case also, if I write number 1, number 2, number 5, number 3, number 4, and number 6. So this one is if I take number 1, it has the right hand side have smaller than 1 or not? No. If I have this one, number 2, no. If I have number 5, have 1, 2, it's 2 in inverse. 2 inverse. If I have number 3, no. Have number 4, no. So the permutation of 1, 2, 5, 3, 4, 6 has only 2 inverse. This case. So when you want to find about the inverse of permutation, the first you look through to the first example. This one. I take number 4. Number 4, the right hand side of number 4 we have smaller than 4 is 3. 1, 2, 3 is 3. Plus take number 3. Have 1 and 2. Plus 2. Start from number 2 is 1. Have 1. So the inverse of 4, 3, 2 and 1 is 6. We have 6 in inverse. In our case, this also. So the total inverse of permutation 3, 1, 4, 2 have 3 inverse is 2 plus 0 and plus 1 is equal 3. This is the total of inverse 3, 1, 4 and 2. 3, 1, 4 and 2. And the next we go to the permutation number of inverse and even number or odd number. Even or odd. In this point is also our starting. I think permutation, or this is kind is permutation. This one is start from number 1. If we start from number 1, the right hand side of number 1 smaller, the number smaller than 1 is no. So we get the number of inverse is 0. 0 we can call it even. Even it means like 2, 4, 6. Odd it means like 1, 3, 5 or anything. It's odd. Even is can divide by 2. Odd it cannot divide by 2. And this one we write about number 2. Number 2 and the right of number 2 have smaller than 2 is 1. So we have the number of inverse is 1. This also we don't have. No. From 2 also no. So is this inverse 0. This one is number 1 we don't have, but number 3 smaller than 3 have 1. Number 2, so we have 1 in inverse. This one I think start from number 2 smaller than 2 is number 1. Number 3 cannot. So it has only 1. If this one I write about number 2. Number 2 have 1. Number 3 have 1. 1 plus 1 is 2. And this 3 is number 3. Smaller than 3 is 2. 1 and 2. But start from number 1, no smaller than 1 is 0. So 2 plus 0 is 2. This one, if I start from 3, is 2. So 2, I start from 2 is 1 plus 1 is equal to 3. This is the number of inverse. If even, odd, even, odd, odd, even, and odd. This is the kind of our permutation and number of inverse, and the classify does it even or odd classification. And the next we start to element of multiplication. The element of multiplication. What is the element of multiplication? Element of multiplication, it means that in this point, if we have example, if we have A, B, C, D, and the determinant A is equal to A, B, C, D is equal to AD minus B, BC. This is they call the element multiplication. Element of multiplication. Example, you have 2, 3, and 3, 5. You have 2, 5 minus 3, 3. This is the multiplication of element or element of multiplication. This one is element of multiplication because 2, 3, 3 and 5 is the element of the matrix. So if 2 multiplied with 5, 2 is element, 5 is element, we call element of multiplication in matrix. This is the definition of what is the element of multiplication. And in general, if they have a matrix n by n, so element of the multiplication denoted by row or column. Row or column depend on to our calculation. Does it row or column? This one is row. This one is row, but we say this one is row and this one, we think this one is column is column. So the row with column or the column with row. This is the element of multiplication in matrix. And example, find the element of multiplication of the matrix below. Matrix 2 by 2, matrix 3 by 3. Proof. Matrix 2 by 2 is written by A11, A12, A21, and A22. This is the element of matrix 2 by 2. Element of multiplication. This one is multiplication. Of multiplication has two parts. Is get from another row, and we know each element of multiplication denoted by form. A1, this one is have any other of the row of the column that we write. Example, we have A11, A22, A12, and A21. This is the first we write only A1 and square, A2 and square. So this is A1, A2, A1, this one, A1, A2, this one, A1, this one, A2. It's not change only this kind of the row, but the column it can be changed from 1, 2, and 2 to 2 to 1. This is the we call this is the element of multiplication of matrix 2 by 2. And about matrix 3 by 3 is also matrix 3 by 3 is matrix 3 by 3 is this we have about A11, A12, A13, A21, A22, A23, A31, A32, and A33. This is the matrix 3 by 3. It's 3 by 3 because it has 3 row and 3 column. So element of multiplication for matrix 3 by 3 is, this is the element of multiplication matrix 3 by 3. How can we get this? How can we get this? We don't think about the sign. The first we don't think about the sign, but why we get about this form? So the next slide or the next page, we have how to explain why we get about this come from to be the element of multiplication of matrix 3 by 3. This is the definition. Uh, if definition, if we have matrix square A is matrix square, so we have the definition. Determinant function is a matrix is written by DE or DETA and get from sum of sign element multiplication of the matrix. This is the definition of the determinant. So we can say determinant I write D. Determinant is sum of all sign sum of all sign element multiplication sign multiplication sum of all sign multiplication of a matrix. Or matrix we call about determinant. Example, we have this matrix 2, 3, 3 and 5, this one. So we get about determinant of A is equal to 2, 3, 3, 5. And we get 10, or we write 2 multiplied 5 minus 3 multiplied by 3. This one is the element of multiplication. This one is the determinant of multiplication. So we can write 2 multiplied by 5 plus minus 3 or minus 1. 3 multiplied by 3. This is the element of multiplication, and this the element of multiplication, and this is the sum, and this all sign. Sometimes have negative, sometimes it positive sign. So we can go back to this one. This one is also the element multiplication of a matrix. This one A11, A22, A23. This is the element of multiplication in matrix. This one is also, and this one is also the, and we get the sign minus or negative. This one is negative. And the next I will explain you what is the why we get this one is negative sign. So if you want to know why it's negative sign, the first I take only one. This one. I take only this one to show you. This one we have about A11, A23, A32. So we take about the column of A11 is 1, column A23 is 3, column A31, A32 is 2. So we get permutation 1, 3, 2. 1, 3, 2, how many inverse we have? We have has this one? No, this one have only one inverse. One inverse is odd. If it is odd, we have we can get A11, A23, and A32 equal to minus sign. The sign is negative sign. So this one also, this one, if we take this one, 2, the column 2, 1 and 3, and suppose 2, 1 and 3. The right hand side of 2 smaller than 2 is number 1. Smaller than number 1 is no, it has 1 in inverse. 1 inverse, so the sign is negative. But this one is positive. Why it is positive? Because we have 2, 3, and 1. This one have 1. This one have 1 plus 1 is 2. 2 is even. So if even become this sign is positive sign. If odd is negative sign, is even is positive sign. This is the way to find about why we get this one is about the negative sign and positive sign. And the next point, this is the sign of by our arrow. The green arrow is positive. The green arrow, the green arrow is positive. This one is positive, and positive. This one is negative. This one is negative. So we get A11, A22, A33 is negative, plus this one 1, 2, 2, 3, 3, 1. A1, 2, A2, 3, and A3, 3, 1. Plus this one is A1, 3, A2, 1, and A3, 2. This is the green is plus, and this one is minus. A1, 3, A2, 2, and A3, 1 minus A1, 1, A2, 3, A3, 2, and minus A1, 2, A2, 1, and A3, 3. This is the sign of positive sign and negative sign. The green, if we start from the left, go down to the right, if we get the positive sign. If we start from the right down to the left, is about the negative sign. Some of other they write A11, A12, A13, A11, A12, A21, A22, A23, A21, A22. This one A31, A32, A33, A31, and A32. Some of them other they You think about this one. This one is plus, it plus sign, plus sign. What about this one? Start from here is minus sign, negative sign, and this one is negative, negative sign. It's negative sign. Start from the up and from the bottom to the up. Up to the bottom is positive. From the bottom to the up is negative. Is negative. So we get about this is the element of multiplication in the matrix. And the next, find about the determinant of the matrix B below. So this matrix is okay. I think you can do this one. I think you can. This one and this one is 3, 5 minus 9 and 2. So we get 15 minus and minus is plus 18 is equal 33. This is the determinant of this matrix A. And about this matrix, you can put 2 rows, 3, 5, minus 2, minus 1, minus 11, and 1. This is so, and then we start from this about positive number, this one, and this one. So we get is this one is minus 22 or 21, plus and minus is minus 40 and minus 8. This one 5 plus multiplication with 7 is 21. Multiplied by minus 1 is minus 21. 5 times 8 is 40. 40 times minus 1 is minus 4. 40. 4 times 2 is 8. 8 times minus 1 is minus 8. And then we start from here. This one, minus and minus plus. Plus and minus is minus. This one is 44. And about this one is minus 24. And this one is plus. Plus it means 35. This one is 35. 35 multiplied by 2 is 70. So we get this one is 88. 88 if we have minus 18. Minus 18 plus 24 is 42. 42, 50 and minus 70, 71. So this determinant is equal to minus or negative 70, 71. This one is also like this. We write 2, 2 and minus 3, minus 6, minus 8 and 1. So we can take this one is minus 16. This one is plus. Plus 9 is 54. This one is plus 4. Minus. This one is 6. 6 and 6 times 8 is 48. This one is minus 6. And this one is plus 12. Plus 12. This one is plus 12. So we get the result. This is the result of our determinant. So this is we call about series strategy or series method. This called. But in this case, when we add two of our column, it can be only 3 by 3. 3 by 3 by 3. This one is 3 by 3. If 4 by 4, 1, 2, 3, 4, 1, 2, 4, 4, 2, 1, 1, 1, 3, 1, 1, 2. So we cannot write 1, 1, 2, 3, 2, 2, 1, 1, and 3, 4, 1, 1. We cannot. This point we cannot. Zeros only 3 by 3 by 3. If we have 4 by 4, we can do another point to find about this. But this one we cannot. And the next. And the next we start in this here. And now we start to the point of this case we have already, and the property of determinant. Property of determinant, it means this in this is if we have the matrix A n by n, and we get determinant CA equal to C power n determinant A. This one, the first they want us to find about the determinant A. Determinant A, we can write this one, we put 2, minus 1, 0, minus 2, minus 7, and 1. So we get our this one we take from this one is 21, 21, this one is 84, this one is 0 plus 0, this one is minus 5, and this one is 0, this one is minus 40, this one is plus 6. So we get this one is 44, 39, 39, and 45. This one is equal to 40, 45. So I get the determinant of A is equal to 45. And about 2A. How about the determinant of 2A? Determinant of 2A, if 2A we get this one, I write in here 2A. 2A, but we can use by this one, or determinant is A is 45. This one is 45. So determinant 2A. 2A, A is 3 by 3. 3 by 3 is equal to 3 multiplied by 5. So 8 multiplied by 40, 45 is equal to 0 is 32, 32 and 4 and 30, 36 is 360. And about 2a, in this point, I write 8 minus 4, 10, minus 2, minus 14, and 20. This one is 0, 2, and minus 6. So I get 8 minus 2 minus 0. 0 is minus 4, minus 14, and 2. So we get this point is so we can calculate this one. This one is 48. 48 and 14 is 2, 3 is 16, 19, 19, and 8 is 19, and 8 is 27. 27. So this is 272. This one is 0. This one is minus 40. This one is 0. This one is minus 320. And this one is 8 is plus 48. So we can calculate this one is equal to this thing. So it is similar to our calculation. Example, in this case, we can calculate this one. Suppose I just omit this one. Is 8 multiply 14 equal multiply with 6 is equal. This one is 6 and 30 plus 0 and minus 40. This one minus 0. This one is minus 320, and this one is plus 48. So we get about this point is and plus 48 is equal to 360. This one 360, this one 360. So we get determinant 2a is equal to 3 determinant a. This is refer to our definition of our property. So if we have a 4 by 4, so determinant of 5a is equal to 5 power 4 multiplied with determinant a. This is the formula of determinant. Please be careful about this point. Example, if we have matrix A is 7 by 7. So determinant of 8a is equal to 8 power 7 determinant a. This is similar. Like our this one is determinant a is 45. So 3 power 2 power 3 of determinant a is equal to 360. And about determinant 2a is equal 360. So we can get determinant 2a equal to 2 power 3 determinant a, this case. Please remember this point. It refers to our this. If a p by p, determinant of ka. So this is, be careful about this point. And the next is theory 2. If we have the matrix A, B, C in order n by n and have only one different row is k, and row k of C equal to row A plus row B, so we get the determinant of C equal to determinant A plus determinant B. Please consider about this matrix. About this matrix. This matrix is, we look all the three. Yeah. All the three. We get about the row 1 is the same, and row 3 is the same. Row 3, but row 2A, row 2B, and row 2C is different. But row 2C is 4, minus 4, and 10. It get from 4, it get from 6, minus 2, and minus 4 we get from 1, minus 5, and 10 we get from 7, plus 3. So it means that C, in this case C equal to A plus B. But row 1, row 2 is the same. It's only row 2. If in this case, it means that the determinant of A is equal to 15. Determinant of B is equal to minus 115. Determinant of C is minus 100. So equal to 15 plus negative 150. So this means that determinant C equal to determinant A plus determinant B. A plus B in this case. So this is the kind of our determinant. And the next theory 3, determinant if matrix A and B are the same order. If matrix A and B, if matrix A and B, A and B are the same order, so we get about the determinant A equal to determinant A multiplication with determinant B. This one is you can to take about the calculate. Example, if you have this one is 20. This is only example. Example in the small one I have A is 2, 3, 3, 5. B is 1, 2, and 2, 5. Example this one. So determinant A is equal to this one is 1 is 1. Determinant B is 1. So determinant A, B is A multiplication with determinant B is 1. So I find the determinant of AB. So I get AB first. I find AB first. AB is this one and this one is 2, 2 and 6, 8, 4 and 15, 19. And this one is 3 and 10 is 15. And this one is 6 and 25 is 31. So it gets this 31, 8 minus 13, 19. So we get about this. This one is 1 and this one is 8. This one is equal 1. So we get determinant AB equal to determinant A and determinant B equal 1. This is the result. And 3 by 3 is also 3 by 3 the same, 4 by 4, 5 by 5. If A and B is the same order, we get determinant AB equal to determinant A multiplication with determinant B in this case. Please be careful about this point. And then we get the next point. The next point, if matrix A has inverse matrix, we have determinant A equal to 1 over determinant of A minus 1. Or determinant A equal to the determinant of minus A equal 1. So we get A. So that this determinant A equal to 1 over determinant A minus 1. Now we get about this case. I find about determinant A. So in this case, determinant A, right here, determinant A is equal to minus 21 by our calculation, and the inverse of matrix. So the inverse of matrix is 1. Determinant of A power minus 1 is minus 1 over 20, 21. So we get about determinant A is equal to 1 over determinant A minus 1. So determinant A is equal to 1 over 1 over 4, 41. Determinant A is minus 41. is equal to minus 41. It is true. So we get determinant A is equal to 1 over determinant of A power minus 1. And about B is the same of A and this point. And the other, please remember, or you can take this one. I can take minus 1 multiply with 1 over minus 1 is equal 1. So it's also the determinant of A multiplication with the determinant of A power minus 1. Why it is get 1? Because in our matrix A power minus 1 is E. So E, if 3 by 3, 1, 0, 0, 0, 1, 0, 0, 0, 1. This is, we get the determinant is 1 multiplied by 1 multiplied by 1 is equal 1. So we get about this. It relates from our inverse matrix in this case. So remember the determinant of A multiplication with determinant of A power minus 1 is equal to 1. Why is equal to 1? Because A minus power 1 is equal E. So determinant of E is equal to 1. If n by n, if I 10 by 10. So the determinant is equal to number 1. And the next 5 theory 5 it means that a square matrix this one is, if matrix A is a square matrix, so we have determinant A equal to determinant transposer of A. This is also this case. If we have example, I take A, I take in small number. A is equal to 1, 2, 3. And the determinant A is equal to 6, 2 is 4. So A transposer is 2, 1, 2, 3. So we get determinant of A is 4. A transposer. So determinant A is equal to determinant A transposer. This point. And the other is also the same. Example, when we have this one, example, we have this one is 5, is 3, is 2, is minus 1, is minus 8, is minus 6, is 0, is 1, is 1. So we get about the determinant of A. This one, determinant of A is equal to minus 9. This is equal to minus 9. And about A transposer. Is 5, 3, 2. minus 1, minus 8, minus 6, 0, 1, 1 is A transposer. So determinant of A transposer is equal to minus 9. So we can take this one and this one is the same. It's the same, so we can find the other of this case. But determinant this point is equal 0. This one is equal 0. This one is equal 0. Why I know this equal 0? Because this row is 0. This column is 0. This row is a 0. On the matrix, if the column or row equal to 0, the determinant is equal to 0. Because we can calculate or we can find the determinant by row or column of the matrix. The next page we have how can we find the determinant by it means by row or by column. So all these three matrix is equal to 0. Also in the determinant, if I write a matrix, if I get matrix A, example matrix A is equal to 1, 0, 0, 1, 1, 0, 1, 0, 1 in this case. So I can find the matrix by this one or this one. If I find this one is, I almost close this one is 2, have only 0, 0, have only 1 and 0. So we have 2. This one is minus 1. Minus 1 is minus 2. So this determinant is minus 2. And example I have 1, 1, 0, 2, 1, 0, and 2, 0, 1. Example this. So I can find by this one. This one, if I take this one to be the stationary, I omit this one and this one. I get number 1 and 1, 1, 2, 1. So we get 1 minus 2 is equal minus number 1. So this matrix is equal negative 1. We can take this point. It's more faster than our calculation or anything. And this one is the formula of the matrix triangular matrix. We have determinant. This one is the determinant of triangle. This one is equal to this determinant. We just only multiply by this. Is 20 is minus 6, 60. This one is also minus 60. This one is also minus 60. So diagonal matrix is minus 60. Upper triangle is minus 60. And lower triangle also minus 60. So if triangle matrix, we just only the determinant equal only the diagonal multiplication of the diagonal of a matrix. If I write 1, 0, 0, 0, 0, 1, 2, 0, 0, 0, 1, 2, 4, 0, 0, 5, 3, 5, 4, 5, 0, and 10, 20, 50, 0, and 1. So this determinant is equal to 1 plus 5 multiplied 2, 4, 5, and 1. So it is equal to 440. This determinant is equal to 440. So we can have other method to calculate in very quickly about this one. And definition 1, if A if matrix A if A is a square matrix and minor Aij denoted by Mij is determinant of the submatrix that result that get from mu I row of matrix A. So in this case, I want to explain this point. What is the minor? Minor is the determinant of submatrix of A. Example, I have matrix A 1, 2, 3, 2, 1, 4, 5, 6, 1. This is the minor of A11. I open this one. And this is MIG or M11 is equal to 1, 4, 6, and 1. So this is the determinant is only 1, 24 is negative 20, 23. So minor 1, 1, it means equal to negative 20, 23. So what is get from? It's get from the submatrix, determinant of the submatrix A. This one I write A. This one is submatrix of A because this is A. We have full, but when we left out all this row and this column, we get only this. So this is the submatrix of matrix A. So minor is the determinant of the submatrix. And now we go to C is we can call C is equal to cofactor. Cofactor is we have this formula negative 1 power I plus j mij. So now we want to find about this C12. So we get C12. C12 is equal to minus 1 power 1 plus 2 M12. M12 it means M12 row 1 and column 2. This one. So we omit this one and this one. So we get this one is minus 1 power 3 and we get minus 1, 3, 9, 5, minus 1 and 6. And this one is 3, 1 and minus 2. So we get the result of this point M1, M12, and M26. C26 it means 2, 4, row 2 and column 4. This one, we omit this one and we omit this one. We just only have this one. 3, 2 also. This one 2, 4. This one, 2, 4. This one, and 3, 2. Row 3, column 2. This one, row 3, column 2. This one and this one. So we get this one and this one for our C3, 3, 2. This is the cofactor of our form. We have this is the result of M 1, 2, C 2, 4, and C 3, 2. This one. And this is the sign of our determinant. The first is plus, minus, plus, minus, plus, minus, plus, minus. This one minus, plus, minus, plus, minus, plus. This is the sign of our determinant. So we can find other row, other column up to us to find about the determinant. And this is the formula of our determinant. This is the formula of determinant by row. This is the formula of determinant by column. So in this case, we can find about the determinant of first row, third row. Example, I have this one. The first row, this one. We find the determinant by first row. First row, if I write here 4, and then we omit 4 in this point, and this point we get this minus 6, 3, 5, and 0. This one is minus 2. 2, we write 2 in this here. Just about the, we omit this one. We have minus 2, 3, minus 7, and 0. And plus 1 is only minus 2, minus 6, minus 7, and 5. So we get this one is 0, is 15. 15 multiplied by 4 is 60. This one is 0. This one is 21. 21 plus this one is 42. This one is minus 10 is minus 52. So we get this one is minus 32. So I find by third row in this point. Third row. If in third row, it means we just find about minus 7. We omit this one and this one. Have 2, 1. 2, 1 and minus 6, 3. Minus 5. Omit this one and this one. 4, 1. Minus 2 and 3. So we get this one is 6 minus 7 multiplied by 12 minus this one is 12. 12 plus 2 is 14. 5, 14. So we get this one is this one is 4. This one is 4. This one is minus 84. outside. I want to find again. This one is 4. I write 4. And I have minus 6, 3, 6, 3, and 5, 0. Plus 2, minus 2. Minus 2, this one. Minus 2, 3. Minus 2, 3. Minus 7, 0. And plus 1. Minus 2, minus 6. Minus 7 and 5. So we get this point is 0 minus this one is minus 60. This one is 0. This one and 24, 21. 21 is minus 42. This one is minus 10. Minus 10 minus 42 minus 52 is equal to 1 minus 154. And about when we take this one, minus 7 is only 2, 1, and minus 6, 3. And minus 5, this one is 1, 4, 1 is minus 2, 3. So minus 7 is equal 6, 12. Minus this one is 5 and 14. So this one is 4, 84 minus this one is 0. And this one is, so it gets 1 and 4. This is the same. So we can take other of row, or other column, but the value of the determinant is the same. So we get is minus 154, the same. Don't think about this. We can calculate it from about the row or about the column, but the value of the determinant is the same. It is not changed. It is the same value. And let A is a matrix M by N and Cij is cofactor of Aij. So cofactor of A did not by. This one is did not. Did not by C11, C12. And adjoint A is equal to cofactor A transposer, and the inverse of matrix A is equal to the 1 over determinant of A multiplication with adjoint A. This is the formula of our inverse matrix that is relevant to the cofactor and the adjoint of A. So remember, adjoint of matrix A is equal to the cofactor of matrix A. So find in this point. We just calculate about adjoint A and A minus power minus 1. Example, this one adjoint A is called about the cofactor. What is the cofactor? What is the cofactor of A? The cofactor of A, this one is mean C11, C12, C13, C21, C22, C23, C1, C2, C3. So C11 is equal to minus 1, 1 plus 1, M1, M11. So M11 is minus 6, 3, 5, and 0 is equal to minus 15. And C12, I write minus M12 is equal to M12, it means this one and this one. We have minus 2, 3, minus 1, and 0. So we get 20, 21. And C13, C13 is 4, so M1, M13 is equal M13, this one and this one, minus 2, minus 6, minus 1, and 5. So we get about this point is minus 10, minus 50, 52. And C21 is minus M21 equal minus M21 is, this one is minus 21. M21, this 2, this one, and this one, 2150. 2150. So it is 5. C22 is M22 equal M22, this one and this one, 4, 1 and minus 7, 0. So equal minus equal 7. C3 23 is equal to minus M2, M23. So it is M23, this one, 2, 3 is 4, 2, minus 1, 5. 4, 2, minus 1, and 5. So this one is minus. So we get about this is 20. 20 plus 14 is minus 34. And 31. 31 equal to M31. M31, this one, this one, this one. 2, 1 minus 6, 3. 2, 1 minus 6, 3. So 6 is 12. And C32 is minus M32 equal M32 for 1 minus 2, 3. For 1 minus 2, 3 is equal to and we get about this point is 12, 12 plus 2 is 14. 14 is minus 14. Because this one is minus. And C33. M33 is MC3, it means this one and this one. We have 4, 2, minus 2, minus 6. So it get is minus 24 plus 4 is minus 20. So the cofactor of A is equal This one A11 is minus 15, A12 minus 21, minus 52. This one is 5, is 7, and this minus 34, 12, minus 14, and minus 20 is the cofactor and adjoint. Adjoint A is cofactor A transposer. So we get this one is minus 15, minus 21, minus 52, 5, 7, and minus 34, 12, minus 14, and minus 20. So this is the adjoint. So A is the 1 over determinant of A and adjoint A. So we find about the determinant A and we calculate with the adjoint A. We can get about the A minus 1. So this is the formula of our inverse matrix by determinant. So we do not need to use about the reduced row A, I, convert to I, A minus power 1. This one. We do not need to use this one because we have this formula. Is easy than that. That's one. This is the way to find about the inverse matrix of matrix A. Now we just go to our next point. Notice that if A, in this case, if A this one is A to B, but B get from A over 4. So we get the determinant B is equal to 4 determinant of A. In this case, 1 over 4 of A. So we get determinant A is equal to 4 determinant of B. So in this case, A 20 minus plus minus and minus is this one is 84. So 104 is determinant of A. And about B, this one is 5, this one is 21. 5 plus 21 is 26. 26 multiplied with 4 is 4, and 104 is the same. But in this case, and about the B from B to A, and only plus about or 1 and or 2, the C and B is the same. Example, I give another example. I give some example of this. I have A is the number 1, 2, 2, 5, and B I get 1, 2, and 3, 7. it means that this one get from R1 plus R2. This determinant is 1, determinant A is 1, and determinant B is also 1. So we can this one. But when we get A, 1, 2, 2, 5, and we get B is 2, 5, 1, 2. This one is determinant, this one is 1. Determinant, this one is minus 1. So determinant A equal to minus determinant B. When we change the row, the value of determinant is opposite from 1 to minus 1. Or if we change C, I can write 2, 5, 1, 2. So we get only minus 1. So if we change about row 1 to row 2 or column 1 to column 2, the sign of determinant is different sign. A plus B just negative. If A negative, B is positive. So it is different sign. But when we get about this metric, in here I write A equal to 2, 4, 1, 3, and B is equal to 1, 2, 1, 3. This determinant is 2. This determinant is 1. So it means that determinant A equal to B to determinant B, because B is from A power 2 of row 1. So we can write determinant B is equal to determinant A over 2 by our to do something. If A equal to 2, 4, 1, 3, but B is equal to 3, 7, 1, 3. This one is get from R1 plus R2. So A, determinant A is 2, and determinant B is 2 also. So it is equal. When we multiplication between row and row, or we plus row addition on or subtraction row and row, the determinant is not changed, it's the same. But when we divide some row with other constant, the determinant is changed from the first by divide by number that we get from the first metric. This is the role of our determinant. Use reduced row to find the determinant of the matrix below. So we use about reduced row. So we start about this point. We start about this matrix. First, reduced row, we can find phi of the matrix. To find phi of the matrix. To find about the reduced row. But when we have a 6 plus 6, we cannot find by a row or column. We just find by reduced row because it is easy. Used by example A and or 2 over 2B. So it means determinant A equal to B determinant B. If from B to C is or1 plus or2, so it's equal to the same to the matrix C. If another thing we can do by step of this matrix. And the next we just look through to the this equation. So when we change this one, this matrix from this determinant A, we change from A1 to A2. So we get B. This one example B. So when we change row, it is minus. And then when we take R1 plus 2 R2, determinant this one and this one is the same. So I write A is equal only minus the same. But in this one, divide R2 by 10. Divide R2 by 10. So divide R2 by 10. This one is 10 divided by 10. So this one is get from this one multiply with 10. So I write multiply with 10. And this one R3 plus 3 R2. So it is not change. It is the same. So I just write the same. So the determinant is this one. You get this one. Multiplication and this one. Multiplication is minus 10. So minus 10, 1, 1, 1 is equal to 19. This point. Example, I want to take this example. I have determinant 2, 5, 1 is 1, 2, 3 and 2, 1, 1. So I write in determinant. So I just take this one is minus. When I change this one 1, 2, 3, 2, 5, 1 and 2, 1, 1. This one. And get from this I convert this one to 0, this one to 0 to be triangle matrix. So this one is R2 minus 2 or 1 or 3 minus 2 or 1. So we cannot change, just only have minus. And this one and 1, 2, 3. This one is 0. This one is 1. This one is minus 5. This one is 0. This one is minus 3. This one is minus 5. Minus 5. So this one I convert this one to 0. So I write R3 equal to R3 plus 3 R2. So it's equal to minus 1, 2, 3, 1, 0, 1, minus 5. This one is 0, 0. This one is 5. This one is 15. Plus this one is minus 20. So this one. So the determinant is minus equal to minus 1, 1, 1 and minus 20. So it's equal to 20. This determinant is 20. So it is the rule of reduced row when we find about the determinant by our reduced row. Please remember when we change the row or the column, the determinant is change the sign. If we take the row plus to the scalar of the row, it is not change. Change only we change about the row or the column, and we just divide the own role. So this is the matrix can be changed, or the determinant can be changed. If we just only about plus this one and this one, this one and this one, the determinant is not changed. But when we multiplication with other constant, or we change the row or the column, so the determinant is changed, the sign of this of the sign. Please be careful about this. And this is the long determinant of 4 by 4 by 4. This one, you see, this one you see about this cost. This cost is it means we just this one from this determinant we write or 1 over 3. So this determinant is multiplication with 3. When this one plus this one minus this determinant is not changed, is the same. But this one is row 2 divided by 2. So this one is 3. So we get multiply with 2. 3 multiplied with 2, this one. And we just do until the next. Until the next, this we get. But this one, or 5 plus 3 or 2 is not changed. We just only 3 and 2 and the determinant. But this one we change. Row 3 multiplication with 2 over 41. So we just multiplication with 41 over 2 because it inverse of this. This one we can write about or 3 over 41 over 2. This one over 2. So this one is this case we write about 42 over 41 over 2. This one is plus is not changed. We just get the same. This result and this result is the same, and this one. So it is the triangle matrix. So we can calculate about the determinant by this one. 1 multiplied by 1 multiplied by 1 multiplied by this one and multiplied by 2 3 multiplied by 2 multiplied by 41 over 2, and we get about this result. This is how to find the matrix, how to find the determinant of the matrix by reduced row. So by reduced row we can find the determinant of 6 by 6 or 7 by 7. It's more order of the matrix we can use about reduced row, but we can use cofactor, or we can use about the row or about the column, because when we use this one it's very difficult to find. But we use about reduced row for more order of the matrix. It is easy, more easy than our it means that then our use about row or column. And the next one we use about Cramer rule. Cramer rule is, it means that we find about x or x1, x2, or x3. X1, x2, or x3 divide by determinant. This is the formula of Cramer rule. So what is A? If we get example A1 x1, B1 x1, x2, and C1 x3 equal to D1. A2 x1 plus B2 x2 plus C2 x3 equal D2. And A3 x1 plus B3 x2 plus C3 x3 equal to D3. So this one is determinant of A. Determinant of A is equal to A1, B1, C1, A2, B2, C2, A3, B3, C3. This is determinant of this one. Determinant of A1. A1 it means we want to find about x1. A1, this is A1. So we omit this one, but we just take this one to fill in this. Determinant A1 is equal to D1, D2, D3, B1, B2, B3, C1, C2, C3, and B determinant D2, determinant A2, and we check this one to fill in this one is equal A1, A2, A3, D1, D2, D3, C1, C2, and C3. And determinant A3 is take this one to fill in H3. So A1, A2, A3, B1, B2, B3, D1, D2, and D3. This is, and A1 is we omit X1, A2 omit X2, A3 omit X3, but we just to take about D1, D2, D3 to fill in our left out column. This is the way to find about the determinant of A1, A2, A3 until An. But in this case of grammar rule, the necessary point is determinant of A is equal 0. If determinant A equals 0, if determinant A equals 0, it means that determinant A1 over 0. If this one is 0 over 0, we find about this one. If this one 0 over 0, we find about this one. 0 over 0 is 0 over 0, 0 over 0. It means that this system or linear equation have infinitely solution, any solution. But this one is 0 over 0, this one 0 over 0, but I think determinant of A3 is opposite 0. So it is mean that the number A over 0. So infinitely. So this equation has no solution. It means inconsistent. If all 0, it means that consistent and have infinitely any solution in this case. And we find about this one. We find about the linear of equation, and I want to show you this case. So you want to write about what is dA, determinant of A is equal 3 minus 1, 5, minus 4, 1 and 7, 2, 4 and minus 1. About determinant A1 is equal, this one A1 is minus 2, 10, 3, minus 1, 1, 4, 5, 7 and minus 1, determinant. And determinant of A2 is equal 3 minus 4, 2. This one is minus 2, 10, 3, 5, 7, minus 1. And determinant A3 is equal 3 minus 4, 2, minus 1, 1, 4, and minus 2, 10, and 3. So we get x1 equal to dA1 over dA. x2 is equal to determinant A2 over determinant A. And x3 equal determinant A3 equal to determinant A. This is the solution of our system linear equation. Please find this determinant, and you substitute in this point. You will get the solution of this system linear equation. This is the way to take our rule to find the solution by Cramer rule. So in this is the something which you start or you will do for our determinant. So in this case is only of our something to start, or you can use about determinant to find about the solution of the matrix, or you can use determinant to find about the inverse of the matrix. So is this the way of you to find? Please do this. Watch this video, be carefully, and when you don't know on the other point, when we meet on our meeting room, we just talking about this, and I will explain you more about some point which you don't know on this video. And thank you very much for your watching this video. And the next of our video we talk about the eigenvalue and eigenvector, and the next we talk about the diagonal of matrix. What is the diagonal of matrix? So before we go to the diagonal matrix, we just know about the eigenvalue and eigenvector. When you want to know about eigenvalue vector, you should know exactly about what is the determinant, because eigenvalue and eigenvector is relevant to the determinant, and the diagonal matrix is relevant to the eigenvalue and eigenvector. So if you want go to diagonal in smoothly, you should study about determinant in clearly, and you know all the point in determinant. So you can go to eigenvalue and you can go to the diagonal matrix. Please be careful, watch video again and again, and not some point you don't know, and when we meet on our meeting room, we just discuss about this point. Thank you very much for your watching this video, and see you on the meeting room. Bye bye.